Okay. So I think we talked about this a few minutes ago, but if we think about the spoken world, most of it, the conversations that we have from day to day, just record yourself for an hour. And even amongst adults, we are often talking about the here and now or the just then, as opposed to far back then. So if it's not here and now, it might be there and then, but a very close there and then. With books, oftentimes it's distant worlds in time and space. I can read Tolstoy in 2019. And Tolstoy was not talking about where he was sitting when he was writing. He was talking about distant places as well. He wasn't talking about himself or the people around him. So we have fictional worlds, fictional people, fictional events, and usually, unless we are the child of an author, written by someone other than who we know. The other thing to think about, and this is important for process, is that what we are listening to every day, these are auditory perceptions, and they're ordered in a very strict sequence. We cannot rewind what we hear. Some of them are clumped together. So if I say Strasvutje, I'm not going to let you hear me. Or I say Ni hao. Sometimes we clump things together very quickly, and sometimes they are spread out. Okay? Whereas print, we can flip back and forth, and when you think about reading, and this is what we do as adults all the time, we don't just read like this, right? We often, when we're reading from a full page, we will actually read a little bit like this, and then our eye starts to skip around, particularly when we get towards the middle or bottom of the page, because we realize there might be a he, or a she, or an it. And we realize that I might have stopped paying attention and I need to check and see who he is, okay? So there are all kinds of things full of sounds, but there's also this world out there. So learning to read not just is a cognitive thing, it changes children's worlds and what they have access to. So let's go into, does it matter what it reads? So when that data point that I gave you about parents' books, if you just count cookbooks, no relation. If you just count automotive repair or any sort of technical manual, things that you go to look at one page, you don't need to have lots of those books. Keep them on your phones. It's the books that are actual books that you read from cover to cover or a chapter at a time. In particular, this is really interesting, and for those of you who do not read as much as you used to, and I'm also guilty, reading literary fiction by adults, young adults, and teenagers actually is related to higher theory of mind skills in adults. So theory of mind, is it important? Well, it's the knowledge that, so I know that you don't know that I am thinking about what you are thinking. Or you assume that I am thinking blah, 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 blah. Okay? The knowledge of other minds, the ability to predict what somebody else is doing. Those are things that are extremely important in our everyday life, and the best predictor of that is not your social IQ or your ability to get along with people. It's actually reading literary fiction. So it's a surprising result as well, but it's something that makes sense if you think about the fact that literary fiction involves a lot of internal conversations, especially something like Tolstoy or Dostoevsky. It's not just external descriptions, right? It's all these characters going back and forth. Okay, so let's go on to the next topic. Now I'm going to answer your question about languages and bilinguals. So, all right, so does the language children learn to read in matter? So this is something that any American child or adult is just unbelievably impressed by. So this is supposedly, I don't know if it's true, I got it on the internet, so of course it's true. It's supposedly a notebook from a child in first grade from 1956. I cannot write that carefully in English, and probably my Russian writing is better than my English writing because my teacher was very strict. But this is something that is a skill for not just learning to write, but also for learning to read. Because if you want to read a note by somebody, you have to know this. So I'm going to talk about both L1 studies and bilingual and L2 reading. There is not nearly enough research on Russian. I spoke with some colleagues at HSE yesterday, and I'm learning more about it, but there's still not nearly enough research on Russian. There's actually more on Russian children learning Hebrew in Israel than I've been able to find on Russian children learning to read Russian. But if you know of great sources, let me know. There are also, in Chinese, so in Russian, Spanish, and Mandarin, learning to read is not just about letters, it's also about how letters go together. So this is actually from a Spanish book, and so it's ba, be, bo, bu, and in Mandarin you would learn exactly the same thing. You would learn ma, man, mi, mu, mao, mo, and so on. And so these letters are lined up not with one thing. In English, we tend to have letters that we don't go into ba and be, we just have the b. So b is for ball. A is for alligator. Doesn't make any sense at all. X is for xylophone. Sounds like a z to me. Okay, so English is terrible. In Chinese, in addition to learning this alphabetic system, Chinese children need to learn not just the individual characters, but the parts of the characters. So this is the character, you pronounce it yong, and it's written just like Russian, in a very specific way. And so you can tell the difference between children who learn Chinese in the United States versus children who learn Chinese in China, because children who learn Chinese can I write on this board? In China, learn that they have to write the character in a very specific order. Okay, so children in the United States might go something like this. Okay, completely random order. And they break apart things that are supposed to be put together. So each of these pieces has a specific name. And so if I don't know how to write something, and a Chinese person tells me how to write something, even as complex my Chinese name is, okay, that's legible to a Chinese person. It is not legible for a Chinese child, because just like Russian, they need to see the individual characters. So which one is that? This one, yeah. Okay? So all of these languages need knowledge of the pieces of them. And we tend to think about the pieces of them as being these written forms. And some of that is important, but there's a lot more to it as well. All right, so I'm going to start talking about what predicts reading in different languages. And vocabulary in every language that's been studied so far predicts reading. Okay, oral language vocabulary. How many words you know is the best predictor of how well you are going to read. And that is true for adult dyslexics as well. Okay, and dyslexia is an interesting example because the biggest problem that dyslexics have when they're reading is encountering a new word. Okay, a word that they don't know, and they have a lot of difficulty usually sounding out that word. So if they have a large vocabulary, a large spoken vocabulary, their guess is more likely to be correct for harder words. Does that make sense? Okay. However, there are differences across languages in how important these other pieces are. So English, forever and ever, what? Oh, English, forever and ever, people have studied something called phonological awareness. And this is the ability to manipulate the sounds of a language. So, if I say the word banana without a ba, what is it? Nana, right? You got it. Okay, so what if I say the word spot without a s? Pot, okay, no problem. What if I say the word spot without a p? Sought. Okay, so I've given you 3 levels of phonological awareness. Knowledge of syllables, knowledge of the initial sound, and being able to separate that out, and then a medial sound. So those are harder. So how about any people who are native English speakers in the room? Awesome. Say box without the k. So what did you first say? Okay, so native English speaking adults typically fail on this. Whereas if I asked the rest of you, say box without the k, you would have just said boss. Right? Why do native English speakers fail?
Because X starts with K. Because the last starts with K. That's the sound.
Yeah, go ahead.
Because it's just one letter. X is one letter in this language.
I said without the k. Exactly. Oh, and the letter X is one letter, not 2 letters. Yeah.
In other languages, the S is combined.
Right, exactly. So it would be like, try and say like sh without the h. You can't do it because it's one sound, but in fact it's the opposite. It's one letter that actually has 2 sounds usually, except in xylophone, where it has one letter and it's completely different. Okay, so English is a horrible language, don't learn it. Okay, so this is a very strong predictor of reading, even though it's typically not taught to young children. It's some random task that a cognitive psychologist came up with, and wow. This idea, the morphological awareness, was not really something that was studied for English children's reading because it wasn't really on the radar. And yet, when we started studying Chinese children's reading, we found that this was not actually a very good predictor of Chinese. Okay, so if you think about Chinese syllables, I can say 车马 自行车, those are 3 syllables. And what's true about Chinese is we don't have these complex consonants. Moreover, we have, this is my name, Tan Xialing. And so this character is one sound. It's a syllable. You don't, when you're writing in Chinese, you don't write t, a, and a tone. When you write pinyin, or the Romanized system, you write t, a, and you have this tone, so that means that its second tone, it's tan and not tan. So if somebody says tan xialing, that means I'm greedy. Okay? So that's something that's really important, but you can't see it in the character. You can't see those individual sounds in Chinese. So does that mean that Chinese isn't important? Or what else does predict reading? So what we found is that actually there's something called morphological awareness, understanding the structure of words in the language that's really important. So original studies with adults found that people's morphological awareness was a good predictor. So if I say, I'm going to tell you a bunch of words. I'm going to say the word for bicycle, truck, train, and like a taxi, okay? And I want you to tell me what you hear over and over again. Ready? 自行车、火车、公共汽车、出租车。So what do you think that means? Something with wheels? To go?
To go.
Wheels?
Transportation.
Transportation?
No idea.
So bicycle, 自行车 bus, 公共汽车 taxi, 出租车 like sedan that you drive around, 轿车 Test your hypothesis. Give me another word to say.
Sheep.
Yes? Ship? What kind of ship? What? A what ship? In the ocean. Okay, 轮船 Skateboard. 滑板 飞机 火车 火车 Oh, for the, yeah, okay. What else? Test your hypothesis. Motor Scooter, 电动车 船 So I just said 摩托车 motorcycle. Okay, so what does 车 mean?
To move, but on the land, on the surface.
To move on the land.
Any other ideas?
Maybe road. Road.
To move on the road, or it means road?
To move on the road.
He says to move on the road. No, it's
No?
Frame for wheels.
What, freight for wheels?
Frame for wheels.
Oh, frame for wheels. Okay. Well, the answer is right here. Vehicle. I had to check to make sure that I didn't have the romanization there. So the answer has been here all along. And this character, so you know how I wrote my name with 3 characters. 自行车 would be 自, not that character, 行车. So they would all have that character 车 in them. And different kinds of boats would all have 船. So that's a system of compounding. And if I said to you, how did you get here today? What would you say in English? I got here by taxi. How did you get here today?
by bus.
By bus? Did anybody drive here? Okay. Did anybody so you got here by car? By car? Did anybody get here by motorcycle? So in English, we can say, anybody get here by bicycle?
It's too cold.
Too cold. You call this cold? What's wrong with you? I'm Canadian. It's cold. Okay, so in Chinese, you wouldn't say that. If you said that, people would just think you're very strange. What you would say in Chinese is 骑过来了, I rode. I 坐车来了, I sat on a vehicle, which means that I took a bus. Okay, I can say, what else? 开过来的, I drove. And we don't say the noun. Okay? So there's 2 things going on with Chinese, is that we know that all of those words are vehicles, and then we also know that when you say things, you can drop that altogether. And my daughter, who is sort of bilingual, when she got to Beijing when she was about 2, she did this each time, and she still does it. The first day she says almost nothing, and then the second day she starts to speak in Chinese, and by the third day she's speaking in Chinese. And on the second day, when she was little over 2, she said to me, 看看妈妈，有一个 taxi 汽车. So she said, look, Mom, there's a taxi 汽车. So she combined, she knew it was a taxi, but she knew that she had to add this 车 thing. Even though she didn't know the word in Chinese, she added it. So that shows that she actually had an implicit morphological awareness of the language that she was speaking. All right, so that's important in Chinese. All right, so I'm going to show you. So are there differences in how reading affects the brain then, according to the language that you're learning? Yes? No? Is it just in visual areas? Probably not. Okay, so I'm going to show you 2 types of studies. We're good to keep going at this point? I assume no big questions so far? Okay, so let's, so this is actually a study of children's word learning, and this is actually showing you across different languages, and I suspect Russian would be in here. Whoops. This is showing that basically in English, nouns and verbs are equal numbers. There are more verb tokens, which they repeat more, but nouns are easier in a whole bunch of ways. In Italian, it's kind of back and forth, but in Mandarin, so I call this the verb conspiracy theory in Mandarin, or the noun conspiracy theory in English. All right, I'm not going to go into too much of this, but I can talk about it if you're interested. It has to do with what children learn early on and why, but I'm going to talk about the structure of nouns, so that morphological awareness. So, any people who study cognitive psychology? Awesome. Okay. So if I ask you to tell me a typical bird, what is a typical bird?
Sparrow.
A sparrow? Any other typical birds? A pigeon. So in cities, pigeons are very common and very typical. Yeah, in the US we might say a robin, even though it's not as common. But that would be a pretty typical bird, right? Would a flamingo be a typical bird? An eagle? Is an eagle a typical bird? Okay, what about flamingo? Is it typical? When you think bird, do you think of flamingo first? Not usually. Certainly you can say flamingo bird, but what about ostrich? If I asked you to tell me things about birds, you would say they fly, and then I would say ostrich. So is that a bird? And you would say yes, but it doesn't fly, right? Okay, so what we were interested in is if Chinese and English speakers would show typicality effects in the same ways because of this category thing. And so we asked people, how typical is this an example of a vehicle? So what's a typical vehicle in Moscow? Taxi, bus, metro, right? Is that a typical vehicle? Sure. Is that a typical vehicle? Not as much. Okay, so we did a study and we looked at people's ratings of typicality, and then we manipulated 3 things, in English and Chinese. So non-transparent, so not all Chinese words are like this. So 房子 is, 房 is building, and this is called a 楼房, and this is garage, and your house would be a 房子, but this is 车库. You didn't hear that 房, right? So this is non-transparent. There is no way to know that this is also a type of building. Okay? Then there are morphologically transparent words in both languages, like paper. So what's this? Note paper, writing paper. What's this? Some very valuable paper. Okay, so these are morphologically transparent. So in Chinese, 信纸,手纸. Okay, it's called hand paper, even though it's not for hands. And then there are words that are orthographically transparent. So we're getting to reading. And so what's this? A fly, and this is butterfly. Which one is a typical insect? The fly, right? Butterfly we don't normally think of as an insect, even though it is. We think of insects as those things that bother us. Okay, so in Chinese though, both of them have this little part, just like this character has this part that means it's something about language. So both of these, this is 苍蝇 and 蝴蝶. Did you hear something similar? No, but if I were to write them, you would see this little character in both of those. Okay? So we call that orthographically transparent. So we did first a behavioral study, and what we found is that English speakers showed very strong typicality effects. They were slower to answer, yes, something is a car or an insect, if it was atypical than typical. Mandarin speakers also showed this effect, but notice that it was attenuated. It wasn't as strong. And so I think, yeah, I don't know what the difference is anymore in these two things. Oh, accuracy and reaction time. Thank you. Okay. So we found it both with accuracy and reaction time. There was a language interaction. All right, what about ERP? So here's where we start getting into your brain questions. So what we found is that answer yes or no. It is a member of the category. We found very similar effects. There's an N300 and an N400 effect, which is kind of like this recognition. And then we found it, so this is in English, this is left and right. And then we found in Mandarin, we found an N300 effect. But look at this N400 effect. N300 effect, and then this N400 effect is attenuated. Then we asked them, yeah, so this is typical and atypical. So we find differences. In this study, we actually did an MRI study, and we found that if we looked at English, typical words versus atypical words, atypical have more interaction. What is this? MFG, who are our neuroscientists here? Medial, frontal, gyrus, thank you. IFG, inferior frontal gyrus. Okay, these two areas are, and superior frontal gyrus. These three areas are going to reappear. Pay attention. So they appear here in English for atypical versus typicality. In Chinese, there are no differences in activation for atypical versus typical. What about English versus Mandarin? So these are the same participants. This is within subjects. These are different participants. What we find here is that there's still that pattern of activation, and then for some reason English is activating much, much more the visual areas than Mandarin is. If you think about this, what that means is that the English speakers are engaging in more visual processing of the stimulus, because we didn't put the words up there, we just put pictures because we didn't want the print to affect it. And then this is true for both atypical and typical items, but you see the difference, so they're processing the pictures more, but what you see is that for atypical items, you see these three areas being activated again, but not for typical items. Okay, so a similar story whether you're looking across languages or within languages. So what about, this is more, what about for children who are beginning to read? So, oh, all right, sorry, I wanted to put that up. So what do you think? If I ask third graders whether they, whether a train was a type of vehicle, what would they say? Yes. If I asked them if a taxi was a type of vehicle, yes. What about if I asked them if a butterfly was a type of insect? Sure, they'd say yes. What if I asked them if a fly was a type of insect? They'd say yes. Which one would they be slowest for? Why? Or if I asked them if a flamingo was a type of bird? Well, what's really interesting is that they show typicality effects for that butterfly versus fly, which in English has the word fly in it, but not in Chinese. 蝴蝶,苍蝇. They are not affected by their knowledge of the characters yet. It has not changed their processing yet. But the morphological ones, the ones that are vehicles, the 自行车, 火车, 出租车, those ones which they've been hearing since they were very young, they do not show a typicality effect for. And when you look at this, so adults, they have almost the same results for the morphological. However, for the orthographic, they actually are very similar to the morphological. All right? So, what happens with the brain? What we find is that for morphologically transparent words, the children don't show much of a typicality effect. So children's brains are much slower. So instead of seeing it, this is like roughly 1, 2, 3. Instead of seeing it around here and their waves are different, we're looking kind of more over here. Okay, so they don't really show much of it, but look at what we see over here. Bloop. And so, yeah. Oops. So LPC is a late positive component, and 400, maybe that is, maybe it isn't. But here we see a much greater difference for those orthographically transparent. So learning to read does change your brain, but being a fluent reader changes it even more. And it changes behaviorally how you respond to some things as well. All right, I want to talk as well about more reading and brain stuff, and I'm going to show you a behavioral result first, and then a brain result. Does anybody need, were there questions that I need to answer before moving on? And are there any questions on the?
If you could go back to the slide with brain imaging and the typical responses for Mandarin and English. No, before that. Yes, maybe when English speaker hears a typical words, he tries to visualize a picture of corresponding to this word. But for Mandarin, he tries to visualize a sign because in Mandarin there are much more specific signs, so it's simpler to visualize signs, not pictures.
So I would call them symbols, not signs.
Symbols, yes.
So the difference between a sign and a symbol. So when you see stop or a stop sign that tells you to do something, that's a sign. A symbol is abstract. The shape of that stop sign, although throughout the world it's similar, it could have been anything.
How do you look at the idea of English speakers visualize pictures while Mandarin speakers try to visualize symbols?
If they were visualizing and relying on visualization, you would not have seen a huge activation difference here. Right? Even if they, so I have another study, and there are several other studies on the visual word form area, which is an area that seems to be specific to characters and numbers and letters. And you would see, and the visual word form area is right back here. So we would have seen some activation here for Mandarin speakers. And, you know, if they were doing it for both of them, we would not see the difference here, but we wouldn't see as big a difference between English and Mandarin there, because they're still visualizing something. So we might have seen this difference, but we should see something going on here for the Mandarin speakers if they were doing that. So my interpretation of the results is that they were relying on their auditory knowledge. And then the children's data is further suggestion that young children, when they're doing the morphologically transparent ones, are also relying on their auditory knowledge, even though they're looking at a picture. So if anything, I might argue that the English speakers might be imagining the word, because both groups are looking at the same stimuli. Didn't go into detail about the design. Did you have a, yeah?
Actually, so if I remember correctly, we studied the stimuli were pictures or words.
Pictures. I skipped over it very quickly. But yeah, so they were pictures, and both groups saw exactly the same pictures. Because I didn't want any activation differences because of the way the words were written. So they're seeing exactly the same stimulus, and there is no auditory, it's just visual.
The task was to say how typical it is for a category. The task was to say how typical it is for a category.
The task
The
was
picture, the task of the subject was to say how
across languages. And we had we spent a lot of effort making sure that across languages they were both rated typical and atypical, and they were far apart, and that they were the same items.
So, did I understand it correctly? I was not mutually exclusive, but how I understood it, but just to make sure. So, it seems to me that the Chinese speakers represent a category by sound, whereas English speakers represent categories by pictures.
I wouldn't say
because
that.
we have this recursive sound, like I said, from ego, so I cannot literally reproduce it. But
I would say it's morphological. In this study, it overlaps with sound, but in the second study, where we have the orthographic one, the Chinese adults did not show a category effect, or typicality effect, but the children did.
No, right now I'm just thinking about this effect of visual processing in English speakers. That's what the problem is.
Yeah, I don't know. Honestly, I mean...
Because in English the categories are not represented directly by sounds. Like actually most of
No, most of the typical ones are the same as the category name or have some piece of the category name. But we had in English ones also that were, ones that were morphologically transparent and ones that were non-transparent. So paper is morphologically transparent. And the second set of results here are about the morphologically transparent versus non-transparent. And when you look at that, even in English, you get much less activation. So this is non-transparent and this is transparent. And so you get less in the transparent ones, suggesting more auditory processing than in the non-transparent ones. Yeah?
How old were the children?
In the second study, the children were about 8 years old. They were in 3rd grade in China. So they start school at 6.
And the first?
The first study was all adults. So this is adult data so this is adults, so this is interesting, right? So here's the morphologically transparent ones, yes versus no, and you get a tiny bit of stuff going on there. And here's the orthographically transparent ones. Notice it's actually starting to look more similar to the English. So the children are not showing the typicality effect for the morphological, right? And the adults aren't showing it. Children aren't showing a typicality effect for the orthographically similar, but our adults are, and yet there's still a difference in the adults. So behaviorally, there's not a difference for the adults. But in terms of brain processing, there is a difference. Okay, so there's much more engagement of those frontal areas, which, as you'll see in a couple minutes, is related to reading in Chinese and morphological awareness. Thank you. Any other questions? Ready to move on to reading in the brain? So I wanted to set that up because language is really important. Spoken language is important. And these were looking at pictures. We didn't ask them to sound it up. Okay, this is a really interesting study in that both groups were looking at exactly the same stimuli. And they were asked a simple question. Just, is the picture a member of the category? And then we would put one word. Okay, so we did have a word up, but this was the actual question we asked them, and for the children, it was, here. This is what their question one was. So they just saw either the word vehicle or the character Twila, but then it went off before the picture was shown.
Were there bilingual English and Chinese speaking people?
We did not do, well, the Chinese speakers were exposed to English, but we tried to get people who failed our English test. So people who were new arrivals and who were not students or faculty, but family members. So there was a little bit of an age difference in the groups.
Sorry if this is redundant. So are English speakers imagining the letters in their mind? Is that what you're saying?
That's one interpretation. Another possible interpretation is that they're processing the picture more deeply and relying on visual cues to tell them. So if I just show you a picture of a flamingo and ask you, is it a bird? You might be looking at that flamingo more intently. Right? We can't tell the difference in this design, but it would be an interesting follow-up.
But actually,
Wait.
but actually, if English speakers were looking more intently at the picture, and given that the category bird is also defined with such visual features as feathers, beaks, etc., etc., wouldn't they also show a reduced typicality effect compared to speakers or people in general who don't look at the pictures as intently?
So, I don't know, but I also want to just bring something back up. So look at the reaction times, though. If they were really looking more intently, then we would expect their reaction time to be higher. But in fact, for the typical items, they were lower. So maybe they were simply relying more on the visual cues. Doesn't mean that they were looking more intently. Does that make sense? And their accuracy is basically identical. Okay. Ready to move on? Okay.